Yeah, so thanks for coming. My name is Nathan Brahms. I'm the VP of Engineering at R2C, and I'll talk about who R2C is and what we do in just a second. But in this talk, I'm going to talk about the tool we develop at R2C, which is called Semgrep. Semgrep is built as a security tool, but the point of this talk is that it is more than a security tool, and I will talk to you specifically how you can use it for development to replace or extend linting that you may already be doing. I'm going to talk about this from two perspectives. One is the developer themselves, and the other might be, say, an engineering manager or another person who is responsible for defining policies around best practices wherever you are. Cool. So with that, let's get into it. So let me get the right keys going. So right, we're R2C, or Return to Corporation, an inside joke for security engineers. It is a software security startup founded with a mission to improve software security and reliability. We're a Series B startup, pretty small team. This picture is actually a little out of date, so we've grown by maybe another row on this picture since our mid-pandemic Zoom photo here. About me, I was a physicist for a very long time, but retired from that career before moving into software. I also like climbing mountains. I used to work for Cisco, and I built a network performance management product there called Meraki Insight. And while I was there, we had a large credit reporting agency security breach. And that really motivated me to start to think about security as a practice among developers. And I think, there's a lot to be said about how security isn't necessarily a priority in teams often. A lot of times, especially product managers might think, hey, this isn't really like affecting my market penetration or something, right? And that's true, but I also think more fundamentally, security is kind of hard. It's very easy to make security mistakes. A lot of the ways you solve them are kind of roundabout and complex. And one thing I realized is that we should actually be doing a better job of making it easy to develop securely. And kind of the point of this talk, right, is that not only should we be doing a better job of making it easy to develop securely, we should be doing a better job of making it easy to develop correctly, where correctness can include security, but it can include all the other things you want to make sure work in your system. So for this talk, I'm going to talk about the problem that we're solving, not just with Semgrep, but Semgrep for developers and for engineering managers. I'm going to talk about some of the tools in the space that you may already be using to address some of these problems. And then I'm going to introduce Semgrep, which is an open source static analysis tool, which can be used to detect problems in a software code base. However, detecting problems isn't enough to solve your problem. And so I will then talk about semgrep.dev, which is a cloud web app that we make and built around Semgrep that actually solves the problem we're going to be talking about today. And then finally, I'll put Semgrep into practice live in front of you with a demo. So before I launch in, does anyone have any questions about the arc of the talk? Cool, I will get into it. So what is the problem? Like I said, this talk isn't about just security. It is about the fact that when we develop, we tend to make mistakes or make inaccuracies or develop incorrectly. So it's about all the flaws in our code bases and how we can address them. So let's talk about some of these flaws, and I'm going to start from the perspective of doing a code review. And this is interactive, so if you want to turn your microphone on, you can help me do a code review, and you can help me spot the problems in our code. So let's get into it. So yeah, I don't know if anyone wants to volunteer this one. We can take a look at this piece of code here. There's some, by the way, I know most people here are Java developers. I'm using Python for two reasons. One is we use a lot of Python at R2C, but also it just tends to write really nice, concise code that's easy to stick on a slide. But you could also imagine this was some Java code. So here we have a cache, and perhaps not the world's best way of retrieving an item from this cache, which is to iterate across the cache and try to pull out the first item in the cache whose object ID is equal to some input value we have here. Of course, the problem is we probably meant to write object.id here, and instead we wrote object_id twice. And this may not even fail your test case. Maybe you write a test case where there's only one object in the cache, your test case works great, and then your code just does not work. So this is a pretty easy mistake to make, just a single character typo, and kind of a hard mistake to catch in a code review. That's one example of something that might happen. I actually did write this one as a Java, in Java code. Hopefully, I haven't written Java for a while, so hopefully it's correct. Here we're writing some string value to a file, opening up the file, writing the value, and then never closing the file. I probably forgot a flush here, but let's say I had one. In that case, your code would work, right? It would write things to files and probably do what you want. And then on your 4096th file or something like that, your code would bomb because it opened too many files. So hopefully that would be something you want to catch in your code review as well. You may also, let's go back here. You may also have some policy that's defined, say, by your security team or by architects on your team. So in this case, the security team has said, hey, every time we proxy a web request in our backend, we should validate the domain of the URL we're proxying to protect ourselves from server-side request forgeries. So we've even made this nice little thing for you called check domain. And every time you proxy a request, please just call check domain on the URL first. It'll throw an error if you're doing something you're not supposed to. And then, of course, someone comes in, they don't know this tribal knowledge in your environment, and they write a new proxy and forget to do this. Also, it can be difficult to catch this in code review. You may have patently broken code. This is an example that only works in Python because Python's a dynamic language. In Python, if you want to write binary data to a file, you have to open the file in binary mode, which would be indicated by adding a B in this mode string here. And here someone's written a function that tries to write binary data to this file, but has opened it in text mode. And so this will fail at runtime when it gets called. So all of these are examples of rather easy mistakes to make that are subtle to see even by a code reviewer. And so let's talk about the panoply of things you need to consider when you're writing code. I think you can kind of express this as a spectrum from sort of nitty details to very difficult problems that are hard to think about. So all the way on one side of this, we have style questions. Do you put braces after around a single line if body, for instance? Do you use uppercase L for long literals? And on the right side of this, you have kind of these meaty problems. How should I lay out my code base? How should I wire up components? Should I use microservices? Should I use a monolith? And questions about business logic. Should I, what kind of API do I want to present to the user? Does that actually solve the user problem? What happens when the user uses my API in a certain way? The entire point of this talk is that on this spectrum of things we need to think about when we're developers, we should only be thinking about the right side. The whole left side is tedious and is generally not the best use of our time. So it can matter, right? It can be like kind of matter in a kind of disastrous way at times. But it's not anything new to think about. Even library choices, generally a team or organization is going to pick which libraries they want to use, at development, at technical decision time. And then from then on, you should just be using that library until you as a team make a choice to change to a different library. So, how do we get rid of this tedious work and make sure we're only spending time on the places where we want to be thoughtful? And that's the question of this talk. I just want to give you an argument for why you shouldn't be spending too much time on this tedious work. Fundamentally, it's grunt work. It's not fun. And we as developers presumably went into this because we like to build and be creative. It's really easy to make these mistakes. I'm sure every one of us has multiple times in our lives, probably on a daily basis, made these kinds of mistakes. And they can be hard to catch, right? It's also just cognitive overhead, right? You're wasting your time thinking about something that isn't really the most important thing for you to be thinking about. And we can also get trapped in unnecessary debates, right? This happens a lot in style, but can also happen in library choices or even use of design patterns, where it may not actually matter which way we do something. It just matters that we do it a way, and we can go on talking about it for hours and hours and hours. But it would be much easier to just make a decision and move on with our lives and not figure out what color to paint the bike shed. Cool. So let's go back to these considerations. Hopefully you're on board that we want to think about the right side of this and automate the left side of this. How do we do it? So style, I hope everyone's using a formatter, and I think the industry is really moving towards the world where, hey, use a formatter. If you want to argue about how to set it up, let the person who's setting up your formatter have that argument and then move on. But that, unfortunately, is still going to leave the rest of this spectrum as needing automation. However, there's some tools we can use to attack the problem. So for instance, linters will catch a lot of mistakes that we make and make sure we're following many best practices. If we have a library choice, say we're gonna, I don't know if people still use Joda time, but maybe you're just gonna we're not gonna use Joda time, we're gonna use Java time. You just like grep for any sort of invocation of Joda in your system. Some design patterns, say like resource leaks, a good IDE can catch for you, but there may be house design patterns. So for instance, our check domain example, that are very difficult to enforce, and you're just kind of left floating in the wind. So kind of what I want to convince you is that Semgrep is a way to answer these question marks. So let's talk about the tools that we do have, and then let's look at where they work and where they don't. So we're going to talk about grep, linters, and beyond. So I kind of want to express this, the panoply of tools as a spectrum again. We have very fast, simple tools on the left, essentially just text search. I don't know if there are other text. I guess you have your text search in your IDE as well as grep. But that kind of general class of tools, which is looking for sequences of characters. And this spectrum extends all the way to what we call full program analysis. So in a dynamic language, an example might be a type checker. So if you use TypeScript, your TypeScript type checker is going to analyze your program, make sure you're using types correctly all through your program. The Java compiler ships with a set of warnings. And these warnings are going to inspect your code and maybe tell you if you have dead code somewhere, right? Because you called something that would abort execution 100% of the time. And then we also have linters, which are kind of intermediate in here. They work on what we call the abstract syntax tree. So they take your code, they parse the code into tokens, and then they essentially are going to operate on sequences of these tokens. Cool. So what do we need from these tools to solve those problems and automate these development considerations that we have? So if you poll developers, I think you would find a few different things. The first thing is that these things should be fast. And by fast, I really mean that you're going to scan code in usually in the order of seconds. grep can actually be super fast, milliseconds, but at some point you just stop caring, right? If it's too fast beyond a human timescale, you just don't care. But once things crawl beyond seconds, you can get into a world where you're going to no longer rely on it as part of your development loop. Kind of an extreme example here is, let's say you shipped your code to a static analysis provider, and they sent you a report a day later. If you're in a fast CI/CD environment, you could have already shipped your code to production, released it to customers. Your PMs could have put it in front of people by the time a problem is surfaced. And then it becomes very hard to change the problem. Obviously, your tools should support your language. If you're programming in Java and your tool is for C++, you're probably not going to use it. We as an industry have defined a large number of industry standards. We can identify a set of common coding mistakes that happen no matter what organization we're in. And your tool should support those industry standards and just come with them. So a good example here, right, is like just the default rule configuration for ESLint, or the recommended rule configuration for ESLint. But on top of that, right, we're going to come up with custom code, ways of using code in our system, library choices in our system, and we're going to want to enforce those in our own environment. So we're going to need to be able to define our own rules, or maybe we're using some framework that doesn't have a lot of support in the world. How would we build rules that allow us to make sure we're using it correctly? And finally, and this point is maybe a little more subtle, is that you want your system to understand the semantics of your code. So this kind of came up in that Python example, right, where we were writing binary data to a file that was open in text mode. There's nothing in the syntax of that code that tells you this. You just have to know that W and WB do different things when you open a Python file. Cool, so let's see how these tools that we've talked about stack up. So on this left side, this very simple side, text search tends to be extremely fast. You can use it on any language, which is written in a stream of Unicode characters, which is very useful. And it's more or less customizable, right? Like if I want to find Joda, I just type Joda in my search bar and I'll find it. That being said, there's kind of a limit to this customizability, because at some point regexes get pretty nuts to write. And the amount of time it takes you to generate a regex which actually does something you want correctly becomes very, very difficult. Linters are still fast enough to use in your development loop, but they can be harder to customize. So for instance, we found writing ESLint rules usually about 100 lines of code for every rule you want to write. But it does ship with a lot of great defaults, industry standards. You may find things built for the framework to use. Great example here is React has an ESLint plugin, which does great in making sure you're using React correctly. You tend to need one linter per language that you're going to use. Actually, Spotbugs is a bit of a deviation there, as long as your language is a JVM-based language. Like I said, they operate on the syntax tree. On the other side, we have this full program analysis. It's significantly slower. Hopefully just fast enough to fit in the development loop most of the time, but generally when you're going to recompile your entire program from scratch, it's going to be slower than you want to wait for. So you may need like a JIT or something like that. And then, this tends to have very powerful understanding of what your program means. So a type checker is a great example of this. If you import some symbol from some library file, your type checker is going to know exactly what type that is and make sure you're using that type correctly. But it tends to come with a limited set of fixed rules that you're never going to modify. You're not going to go edit the Java compiler and change what it can detect in your code. So I've purposely left a hole in the middle of this this graph, and that is what I want to fill with our tool, Semgrep. Semgrep is what we would call lightweight static analysis, and it has a power level which kind of sits in between linters and full program analysis. I'm going to run through, each of these bullet points when we go and talk about like the details of Semgrep. But it tends to be about as fast as a linter. It works with semantic support for most languages that people develop with nowadays, but then can support syntactically any language. It is extremely easy to customize and build your own rules, and also comes with a registry of R2C written and community written rules, and then also bundles of these rules into packs that you can just download and use easily. And finally, it has semantic support. It is not as extensive as the full program analysis tools, but can give you semantic information within a single procedure. And I'll go into detail moving on about that. I'm going to stop here and pause for about 20, 30 seconds, and I just want to ask people what questions you all have.
So let's forgive me for saying this, but maybe I misunderstood the point. But in general, how this all works in conjunction with unit tests, because they're now, after linters kind of give you like good rules. Let's say make sure that you're following certain standards. But semantic behind your code is usually something that you validate through unit tests. So
this is a fantastic question. So I really appreciate you asking it. It is my argument that the main point of unit tests is not to validate the semantics of your code, but to validate the business logic that you actually are trying to support with your code. You can, of course, use unit tests to validate the semantics of your code, right? I could write a test for my binary logic library function. You probably should write some tests, and it will crash when I try to write binary data to that file. But wouldn't you much rather have your compiler or type checker just tell you, saying you never had to write that unit test in the first place? So I think that kind of goes back to that same question of like, where should we be spending our time thinking and spending time? And my kind of like argument is, hey, similarly when we're writing tests, let's spend our test writing time writing it to make sure we have the right business logic in place. Now that maybe is like very opinionated, and you may disagree with me, and I'll accept that. But there are kind of some other places where unit tests may be a little more difficult too. You tend to have to write a single unit test for every project you're working on, which means if you see that similar kind of code or flaw in a new project or in a very slightly different library function that you've written, a different library, you're going to have to write that unit test again over and over and over again. Whereas if you wrote a rule in a static analysis tool, that static analysis tool, you should be able to write that rule once, and it should catch it on every single instance in your entire ecosystem. Hopefully that answered your question. I'll accept disagreement too.
No, it's not a disagreement. I'm just clarifying thing. How does this work? Another question. Forgive me for monopolizing your time. Essentially, how this goes with security.
Great.
There's a lot of good security practices, and I was using some security static analysis tools, and I know that people are right now, it's a big thing, writing secure code. So how this Semgrep works with that?
Yeah, definitely. We'll also get into some examples, but at a high level, there are different possible issues with security, just like there are different possible issues with code. Code can be insecure on its face. So an example of this is if you initialize your TLS connector with TLS version 1. I just need to glance at that code and tell you, hey, you used the wrong TLS version. there's more complicated security problems. Like, let's say I am reading some user input from a web request, passing that to a controller function, doing some processing on that user data, and then writing that into a template, and then rendering that template back to the user. Is there a reflected XSS in this server? That can be a very complicated question to answer. And that's kind of more this full program analysis kind of need. And then on top of that, there's more runtime security issues, which really isn't covered by the umbrella of static analysis at all. And you might need to use something like a fuzzer or ZAP, a runtime security vulnerability detector, to discover those. Similarly, you need to use end-to-end tests to detect a lot of runtime flaws in your code. So this is really about statically identifiable problems. So, if we restrict ourselves down to statically identifiable problems, we can kind of map those security problems to similar kinds of coding flaws outside of security. One of the things we like to do when we talk about Semgrep is talk about writing code with secure defaults. So a great example of this is if I am rendering HTML in a template, it can be very easy for me to accidentally render a raw string and allow someone to inject code into my rendered HTML. However, if you're using the React framework and you're always rendering with React, it will not let you do this unless you call dangerously set inner HTML. It is then very trivial to just go through some code and make sure no one ever used the term dangerously set inner HTML outside of a comment. And you can then assert, hey, I was using React securely, and I do not have reflected XSS in my code base. This is what Semgrep really excels at. Define the way to use your code so that it cannot be used incorrectly. We would call that in the security world a secure default. This is kind of what I'm alluding to when I talk about house policy. You can then use a static analysis tool like Semgrep to validate that you're using that code in that way, and then assert you do not have the flaw because of it. You don't have to theorem prove that you don't have the flaw. Thanks for the question. I'm going to move ahead in the interest of time, and let's get into talking about what Semgrep is and how it works. I'm just going to give you an example of how you would use Semgrep as a tool. So Semgrep is a command line tool. I will pass it a rule file. A rule file is just a YAML document. So at the top of this here, I have an example YAML file. So I'm going to set for each rule, I'll specify a name for the rule, or identifier for the rule, which languages I want the rule to fire on. So if I have a polyglot code base, Semgrep will go find just those languages and pull them on my code base. A message I want to show to the user if the rule is detected or fires on the code base. And then maybe like a severity level. And then finally, kind of the meat of the rule is this thing we call a pattern. So here, the way you write this pattern is you essentially write the code you are looking for. If anyone use something like structural search in IntelliJ, it'd be similar to that. And the only difference between it and the code you're wanting to write is that you can use this $x looking thing here, which we call a meta variable. It can be $ whatever the heck you want. And that meta variable will match an arbitrary node in your syntax tree. So here we are looking for any use of the equality operator where the left-hand side of the equality operator is identical to the right-hand side of the equality operator. And you could tune this, depending on the situation, to be syntactic or semantic. We can get into what this might look like in a semantic world later. But here we are using it to find that cache iteration bug that we talked about in our code review. And here I'll just say, hey, you probably did something wrong because you should never be just comparing the left and right hand side with the exact same value. And that'll help you find your typo. Cool. Like I said, we wanted to look at speed. We wanted to look at the rules that are available, how customizable the system is, how semantically accurate the system is, what languages it supports. So I think hopefully I'm convinced you that it's rather easy to write a rule in Semgrep. This is however many characters, and I can catch a large class of bugs with a simple rule like this in Semgrep. But let's talk about speed. I just wanted to find, we have a TypeScript repo at R2C, and I used 3 tools to find uses of console.log that weren't in comments in our code base. So I used grep. It ran extremely quickly and told me 61 places where we used console.log, none of which were actually true positives. So if you add in the amount of time it took me to run grep and the amount of time it took me to go and sift through all 61 of these false positives, it took an extremely long time. We also used ESLint, which relatively quickly told us that we weren't using console.log improperly, and Semgrep, which has speed on the parity ESLint. So, it's a little bit slower than a linter, but effectively, from a human standpoint, about the same. The languages Semgrep supports on a semantic level are listed here. So these are all our GA languages. That means that we support basically every language feature in the language, and we can match basically any construct in the language and find it. Alpha languages are ones that we have released to the public, but you will probably find bugs, and we would encourage you to report those bugs to us so we can fix them. One thing I want to point out is this generic mode. Generic mode turns Semgrep purely into a syntactic static analysis tool, but it can operate on any space delimited set of tokens. So you can use this, for instance, to look at Terraform files, or what's your favorite language? MATLAB, I don't know, whatever you want. Shakespeare language, go for it. And then we are also adding full semantic support for a number of languages coming down the pipe. And then, kind of last, I wanted to talk about how these semantic understanding can help you in examples. So on the left here, let's say I just want to audit a code base for every time I write to a file. In Python, I would just look for anything that I open with W mode. And of course, I may not, in the actual syntax tree, call path.openW. I may actually have like a constant defined somewhere or a variable defined somewhere that defines this W constant, and then use that. And with semantic understanding, you can realize that the content of this variable is the thing we are looking for. A more complicated example might be looking for a code injection, or sorry, a SQL injection vulnerability. Here I am looking for any user input data that comes from a Flask request object, then gets written into a raw SQL query. However, I will admit that if you cast this thing to an integer first, you cannot actually inject into the database. And so this is looking for essentially tainted data going into a sensitive sink. Cool. Last, I just want to talk about the rules that we do provide. We provide over 1,300 rules served from our registry. These are a combination of rules written by us at R2C and rules written by the open source community. We provide rules written for a large number of popular web frameworks and infrastructure frameworks, so for instance, Terraform. We've also ported rules from existing linting tools. So an example here is find_sec_bugs. An interesting difference between how find_sec_bugs operates and how Semgrep operates is find_sec_bugs is going to operate on your Java bytecode, which means you need to compile your code before you can run Semgrep. So this generally means that if you've installed find_sec_bugs in like your CI system, you have to delay reporting any issues until after the compilation phase has finished. Whereas with Semgrep, you can just operate, say, at pre-commit time directly on the syntax of the code. And then we also have an array of security rules that will give you coverage against the top 10 OWASP's most impactful security vulnerabilities. Yeah, so that's Semgrep. I want to talk a little bit like how it was built and how it came to get to R2C. Semgrep started out as an academic project at the research group of Julia Lawal at INRIA in France, looking at trying to build a system to automate evolutions of the Linux kernel. It was then taken to Facebook, where it was used to develop program analysis for the PHP stack at Facebook. We then brought it in to R2C to help us write rules more quickly. So we were writing rules in a linter, and like I said, we would find ourselves having to spend maybe a week writing a rule, hundreds of lines of code with test cases, debug all the edge cases, go back and forth. And by bringing in Semgrep, we could rapidly improve our iteration velocity in developing those rules in-house. We realized that no matter how many rules we wrote, people were still going to need to customize the system for themselves. So we started promoting Semgrep as an open source tool for end users, not just for ourselves. Like I said before, Semgrep itself isn't going to solve the actual problem of how you automate your development. It will just find things in your code. So we have then been working on semgrep.dev, which is a cloud app that provides a full-featured end-to-end solution for security engineers to manage security policy in their system. However, even if you are not a security engineer, you can use this to manage development quality policy in your own code base. And kind of the last little thing to talk about is that the first author on this paper, Yoam Padulu, is completely coincidentally the lead PA engineer at R2C. Cool, so let's talk about this application and how it can be used to solve problems in your own system. So the loop you might adopt is you might go to our registry and try to find the rules you want to run on your system that you can just use out of the box. This is kind of like setting up a linter and running it for the first time. So let's say you have a Django web app, you might just run semgrep-config p/Django. It says give me all the Django rules on my code base, see what you get. You will probably find there is something you want to catch that you did not with one of these built-in rules. So you can go to our editor. It's kind of like a regex 101 environment where you can write your own rule. In this example, I've just been trying to make sure that the audit mixin I wrote for SQL Alchemy was used in our system. If you wrote a rule and it applies outside your environment, you can contribute it back up into our registry and get your name on a rule and have people start using what you wrote. Once you have these rules decided, you can then deliver them to your developers. They can see findings in their IDE. You can then define how you want to affect the developer's workflow when they see a finding using a policy. In this example policy, the configurer is setting it up so that the developer will see an automated comment posted on code review, but the rule will not actually block the developer from deploying the code. Here's an example of what that would look like. The developer will post their code review. The automated CI system will run on their code review and paste a comment. At this point, the developer can say, oh my gosh, I need to fix this. Thank you so much. They could mute the finding, or they could report back to you, hey, this rule doesn't work properly. It needs to be edited. And you can just open up the editor, adjust the rule, recommit it. And then finally, if you are the person managing the policy, you're the security engineer, the EM, the tech lead, the architect, you can get a feed of the findings that are actually being seen on your system and seeing what issues developers are running into most often. One thing we do is we deduplicate these results. So, if the same code review runs Semgrep 18 times, you're only going to see the first time the issue fires. And then if this isn't sufficient for you, you can always wire this up to a Lambda or what have you, wire it into your data warehouse so you can go and analyze these results later. Or you can use our in-house analysis and try to, say, analyze on a rule-by-rule basis which rules are being fixed, which rules are being muted, which rules are being completely ignored by your developers. Cool. I'm going to pause again for questions before I launch into a demo. So open the floor just for 30 seconds for more questions. Well, great. Let's get into the demo. So in this demo, I am going to just be walking through building a Flask app to build a simple API. So let me do some Git magic. I think we're set up properly. Just to confirm, people can see my IDE, correct? Thumbs up, thumbs down. I'm going to assume no news is good news, and you can all see my IDE. So here, I don't know why I built this, but I've just built this JSON API that reflects data back to the user. So any post that comes in, I'm just going to parse the request entity as a JSON blob, pull out the data element, and then spit it back at the user. So there it is. Let's make sure it works. So we'll run our app, and then we will curl our web endpoint with this data element. And hey, it works. Great. I'll write a test case, make sure it works, post it. Everything's great. Of course, what I will rapidly find is some user will come along and they will not use my API correctly, and they'll do something like this, and I'll get a server error. Client errors should not yield 500s, so I should do something different. And let's see if we can spot the problem. Well, the problem here is that there's no data field in the JSON object that came in. And so when I tried to index my JSON object, it just wasn't there. I got a key error, and Python blows up. So what should I do? I could probably write a whole bunch of code here that does a whole bunch of validation on this request object. That's not very scalable. So let's define a policy and say, hey, we're going to use a deserialization library that automatically validates whatever request entity gets sent into our system. So let's check that out, and I'll show you what that looks like. So here I've used a Python library called Marshmallow. It's a marshalling unmarshalling library. I've said, hey, whenever this thing kicks out an error, just return a bad request to the user with the error message. And then on a per request basis, all I need to do is define the object I want to map to in this schema object. So here I'm saying, hey, there should be an error if you don't save data. So if we go and restart our web server and run this curl again, you will see I get some useful error message that gets sent back to the user. You can do more fancy stabs at making this break. Thing I've hidden here is I haven't actually added in the validation that the entity itself is a JSON object, which is something you'd also want to do. Okay, this is great. We can commit it, deploy it, life is good. But that's kind of insufficient, right? Because I'm going to have an engineer come on the team who has no context about this, and maybe it's buried in a doc somewhere, and they didn't have their coffee in the morning. They read the doc, and they don't know that they're supposed to use this serialization library. So what I can do is just make sure that everyone who writes a web endpoint uses our deserialization library with Semgrep. So I'm going to come here to Semgrep, and I'm just going to write a rule that validates that I did this the correct way. So the first thing I want to do is come up with the good and bad demonstrations of the code usage. So let's get the good one first. We don't need all this data. So I'll just take part of it. let's first come over here, stick it all in here. Nice thing is because this is only procedurally semantic, I don't need all the, I cannot not tweet. Interesting. We'll just leave all that there. Then I want the bad code. Check out the bad code. We'll copy that. And we'll stick it in here. Great. And then we will mark that this code is good. And we will mark that this code is bad. We'll go to a name, unvalidated Flask JSON. Okay, great. And now we just want to see if we can find this bad code. So the bad code that we're looking for is any request.get JSON. So if I run this, we will see that we do detect request.getJSON, but we detect it in both the good place, the place that should be good, and the place that we don't want to detect it. So what we'll do here is say, hey, don't fire if we are doing the schema validation. We don't know what the schema object name is. So we'll say schema.load ... That ... is kind of like your star operator in regex. We can run this again. And I'll see you only match here. One little wrinkle here is this request might not be imported from Flask. So I'm actually going to assert that it is the Flask module's request object. And here we start to see some semantic understanding. So we imported this request object from Flask, and Semgrep understands that this is the Flask request object. So if we have if we shadow the variable or something like that, it won't fire anymore. We automatically run some tests here, and we see this one fails. It's because we haven't told it the right ID name. So we'll go stick that in by editing the rule definition YAML here. And then we'll also give the user a nice message. And we'll say, there's kind of three things we want to do here. We want to tell the user what the problem is. So we'll say unvalidated Flask deserialization. Why is this bad? This can cause server errors on incorrect client input. Then we want to tell them how to fix it. Use a valid marshmallow schema to validate this. We'll just neaten up this message line. Go. Run this again. And we see here all tests pass, and we have a useful error message that can be shown to the developer. The next thing we're going to do is going to save this to our personal namespace in Semgrep. So we'll just save this. Great, and so now we've written this rule. So I've already set up this project as a project here, Semgrep Flask demo. And the only thing that's useful from this page is knowing that the policy that we're enforcing is the Semgrep Flask demo policy. So we'll go over to that here, and we can go add the rule to this policy. So we'll go add it to Semgrep Flask demo. I've actually already added this rule here. This is just an edit to the existing rule, but we can go and see it here. So there it is. We can see it's a Python rule. And if we look at our settings, we see we're both blocking the build and rendering a comment to the developer. So now let's say I am this developer who comes in. So I'll add a new endpoint. I'm just going to go and log some lines here. Just spit out, reflect the lines, but also just to a log instead of back to the user. But I did this incorrectly, right? I didn't use our deserialization library. So now I'm the developer. I'm going to go push this to our source control system. And I will go and make a pull request or merge set in GitHub here. So let's go and do that. Okay, so there we go. Wonderful. We'll go create this pull request. Hopefully your developers have better commit messages than I do. And then we will see that this request kicked off a check in our CI system, which is now running, and we can go look at this. So, actually most of the time this is just pulling a Docker container and checking out our code base. And then once it runs, which it is doing now, shouldn't be too long. It is now looking for any issues in our file. We'll wait just a few seconds for it to do that. Okay, so it's found 2 issues in our file. And now it's trying to say, hey, what issues were in this file before this pull request even started? So one of them was, I don't even know what it was, but presumably some other issue with how we're using Flask, probably not like using it in the correct production mode or something. But then it says, hey, look, we have unvalidated Flask deserialization. So if we go, now probably the developer is never going to look at this, right? But the only thing the developer is going to look at is the front page of their code review here. However, Semgrep is going to go and comment on their system and say, hey, you made this problem. I, as a developer, can read this and understand why I should change it and how to. Maybe if I was getting really fancy, I might add a link in my description to the documentation for this library. So great. So I'm the developer. I now want to change this. So I will go change that. Maybe something like this, right? Now I use a log schema. Go update RPR. And now all my checks have passed. We have the green light. Sorry, let me reload this. Oh, I guess it's running right here. We'll wait for this to finish. So again, this few seconds it takes to do the scan. And now it's going to baseline our scan. Great. So there were no findings. So if I go back here to the conversation and then hit GitHub with a quick refresh here to get around their UI problems, I will see that all checks have passed. We're good to go. This is outdated, so I can just resolve the conversation. If I looked in the diff, the comment doesn't appear here anymore. And I can now merge my pull request. Cool. And that is the demo. And just head back here quickly, just to kind of give you a summary here. So, the whole point of this talk is there's a lot of stuff we do when we're developing, which is common mistakes. And then we can get automated tooling to get ourselves around those. However, this automated tooling has requirements. It has to be fast. It has to support the language we're in. It has to have industry standards, but allow us to be customizable. And also has to understand the semantics of our system. And Semgrep is that tool. So thanks a lot for your attention. Really appreciate it. I'm just going to leave here with some links, and I will take questions.
Do you have a Semgrep tool for validating scripts, these, how do you call them, rules?
We do, yes. Semgrep for Semgrep, yes. So there's kind of like two levels to this. One is we have YAML is one of our supported languages. So we can then make assertions about the content of the YAML file. So an example here, right, is if, let's say you just looked for the same pattern twice, or you said, hey, I want to find this pattern, but I also want to assert that it is not inside the exact same pattern. That will never find anything, right? These are kinds of common mistakes that you can make, and we can just write a rule in our YAML language to identify this. There's kind of more complicated ones, which are more related around the performance of the rule that you write. So for instance, if I just put a $X as my pattern, it will just match every single thing in my entire code base. And then that can cause performance issues. So we can like give people a warning like, hey, this is going to match everything. It's not very useful to you. Find some other way to do it. On top of that, we can add in yet more semantic understanding than we can provide with just Semgrep alone by building what we call a meta checker, which is in the works right now. So essentially, it's like a compiler for your Semgrep rules. I should also point out there are things we also allow you to do because you're reusing YAML. We can provide templating for the YAML, so you can actually programmatically generate rules as well.
Thank you.
Sure. Well, Amelia, I think there might be no more questions, so I'll turn the floor back over to you.
Thank you so much, Nathan. Really, really appreciate it. It was a fantastic presentation. I'm sure everybody got a lot out of it. Okay. Well, if there aren't any other questions, we'll go ahead and end the call. Thank you, everybody, for your time. And Nathan, thank you again.